This is a second video on factoring. We're going to be looking at factoring a difference of two squares. This is really the second step to factoring. The first step to factoring, as we saw in the first video, is to look for the greatest common factor, which we call the GCF. And then the second step is really dependent on the number of terms. So we're going to be looking at a situation that has two terms, and the situation consists of a difference of two squares, meaning a difference of two perfect squares. So it's often written like this. So if we can write a binomial, that is a polynomial with two terms, as a difference of two squares, then we can factor that as a plus b times a minus b. So remember, this term right here, that is a perfect square. And b squared is a perfect square. So oftentimes, it's not going to look like it's in that format. You know, you might get something like, I'm going to do something without even variables, 16 minus 9, right? We could rewrite 16 as 4 squared, and we could rewrite 9 as 3 squared. So now we can see that this is a difference of two squares. And we can factor that as a plus b times a minus b. Now let's just see why that works. If we multiply this out, we get a squared minus ab plus ab minus b squared. Those two terms cancel each other out, and you're left with a squared minus b squared. So you can see that the right side, a plus b times a minus b, is equal to the left side, a squared minus b squared. So let's look at an example. Okay, so in this example, we have 3 minus 12x squared. 3 is not a perfect square. 12 is not a perfect square. But what I want you to get into the habit of doing is always, step one, look for greatest common factor. Sometimes there will be a greatest common factor, sometimes there won't be. So in this case, they have a greatest common factor of 3. They're both divisible by 3. So remember, we're going to write that with the greatest common factor outside the parentheses, and then the leftovers on the inside of the parentheses. So 3 divided by 3 is 1, minus 12 divided by 3 is 4x squared. And you could distribute that 3 and double check that that's correct. So now we're going to factor the leftovers. The leftovers are a difference of two squares. So we could see that 1 can be written as 1 squared. 4 can be written as 2 squared, and x squared is obviously already something squared. So I'm going to rewrite that again, just combining the 2 squared and the x squared. I could rewrite it as 2x squared. Okay, they both raised to the second power, so I'm able to use the properties of exponents and rewrite that. So now I'm going to factor the leftovers as a plus b times a minus b. So before I actually do that, let's just identify that here a is equal to 1 and b is equal to 2x. So a and b are just the base. So now we could write a plus b times a minus b. And we could distribute all of this out. So this is our answer. This is completely factored. We cannot factor 1 plus 2x times 1 minus 2x any further. But we could multiply this whole thing out, and when we do so, we should get what we started with, okay? So check by expanding. And when I say expanding, I just mean multiplying it all out. Now let's look at one more example. So we have x plus 2 quantity squared minus y squared. So this is a difference of two squares where our first term is x plus 2 squared, so our a is x plus 2, and our second term is y squared, so b is y. So we're going to factor this as a plus, let's write this out, a plus b times a minus b. So a is x plus 2, I'm going to put that in parentheses, plus y, and this is x plus 2 minus y. Now I put a lot of parentheses here because I'm substituting in, but none of these parentheses are actually necessary. I like to put them in there because, see that minus sign? If the second term here, if that had two terms, right? If that was the x plus 2, that minus sign would make a big difference. We'd have to distribute that. In this case, because it's only one term, it doesn't really matter. So I could rewrite this so that it's a lot simpler to look at. Oh, excuse me, my pen is kind of acting up here. So this is x plus 2 plus y times x plus 2 minus y. And we cannot factor either one of those any further. So that's our final answer. Now, before I go, let's just look at a couple of examples that are not perfect squares, okay? So let's say you had 16y minus 9. Okay, you might look at that and say, hey, 16 is a perfect square. We could write that as 4 squared. And 9 is a perfect square. We could write that as 3 squared. But we have this y here, and that y is not squared. And therefore, this is not a difference of 2 squares. And that's, I wrote dots. That's just my abbreviation for difference of 2 squares. Okay, that y would have to be squared in order for me to be able to factor that as a difference of 2 squares. And let's look at one more, right? We could have 8x squared minus 25. Guess we're going to look at two more. So now I can rewrite this as, I could rewrite the 25 as 5 squared. But this 8 is not a perfect square. Be very careful. People always get tripped up here, and they want to write this as 4 squared. Okay, remember, 4 squared is 16. Okay, it's not 4 times 2, which is 8. So because 8 is not a perfect square, this is also not a difference of 2 squares. And then the last one, say we have 36 plus 9x squared. Okay, so now we can look at this and say, hey, 36 is a perfect square. I could write that as 6 squared. 9 is a perfect square. I could write that as 3 squared. X is already squared. But this is not a difference. This is a sum. So this is also not a difference of 2 squares. So you want to be careful when you're factoring. Okay? Just because you have two terms does not mean that you can factor it as a difference of 2 squares.